Greetings, this is Artie from Artifact Electronics. Found this guy in a thrift shop the other day. It was buried between a bunch of Dance Dance Revolution mats and We Fit balance boards. It was camouflaged pretty well. I actually straight looked at it and walked right past it. And a few seconds later, my brain tells me, wait a minute, that kind of looked like Tektronix's color scheme. Even though the sides color, it doesn't show up well in the video, but it's more of a dark blue-gray color. But the front panel sure looked like Tektronix, and I walked back and I removed all of the garbage around it, and this is what came out. It does start with a T, but it's a Telequipment, which I had never heard of before. It's a dual tray scope, and one of my criteria for buying really weird stuff is something like this. I will look up on the internet immediately and see if there's any sort of documentation for it. I looked it up, and to my surprise there was a user manual that contained schematics. So off we went. Now, I know in one of my recent videos I said I'm not going to reveal prices anymore, the prices I paid for it, so I don't get into negotiating wars with future buyers. But this one was kind of expensive, so I'm going to break my own rule. Well, I won't. Yes, I will break my own rule and let you know. And so get ready for it. This one was expensive. As you can see, this one cost infinite dollars. Oh, you can see it better like this. So I was kind of intrigued, I thought it must be something really special if they want that much money for it, and maybe I can talk them down. But I find that quite unique to have an old weird scope like that be so expensive. Another intriguing part of it was that it has no serial number, and it is made in Guernsey, CI. Now, when I hear Guernsey, I think of the cows. I used to live in the Commonwealth of Pennsylvania, and there were lots of Guernsey cows there, but I had to refresh my geography, and I guess Guernsey is one of the Channel Islands. That's what the CI stands for. And it is not part of the UK, but it's a dependency of the UK. So for all intents and purposes, this wasn't made in the UK, but it was made in Guernsey. So there you have it. And finally, let's get into what this thing actually does. This was built in the late 60s, and this is not a lab-grade instrument, but rather a technician-grade instrument. As you can see from some of the trigger selection here, it is kind of targeted at people repairing TVs. So let's see what this does. I did not turn it on in the store. That didn't seem like a very good idea. And considering its price, of course, I wanted to do all I could to save it from any further damage. The power cord is somewhat frayed at the plug, but that's only the insulation and sheathing around the wires. The wires are good. There's no copper showing. It will need to be replaced if the scope is proves to be worth it. But for now, let's see what it does. I actually powered it up with a Variac already, very slowly, and now I'll show you what it did or didn't do. So here's the power switch. The power light illuminates. Over here, the scale illumination does not work at all. So we give it a little bit of time to warm up, and nothing's happening. So let's change the trigger level on it. Out of calibration. Doesn't do anything. But then there's a stability control behind it. And from a previous scope, I had no idea what that was, but I guess it kind of tweaks the internal time base oscillator. So what this looks like, when I changed the time base, you see, sometimes a partial trace flashes up. So the high voltage is good in this. Oh, there's something. So we have a live CRT on it, but I finally remembered that the stability control is what really gets the time base oscillator running. That was, of course, the last thing I tried, and there you go. We do have two traces, but they're really bright. And you know what? I can't adjust the brightness. It's called brilliance, and it even shows up a little brighter on the camera than it is in real life, but it's pretty bright, and we definitely have a problem in the screen intensity adjustment. So let's go inside and have a look. So right here is the power supply and CRT circuitry. I mean, this is what it looks like, but we are interested in the brilliance pot, which is right here. So what it does is it taps off here where it is supplied with negative 1050 volts, and up here it's negative 950 volts. And the way that is achieved is they put a 100 volt Zener diode here, and that gives you a potential of 100 volts across this, a pretty stable reference. And as you change this pot, you change the voltage going up to the CRT. So, I mean, it's a simple voltage divider over here, so looking at this is okay. So, it looks to me like it's in full brightness. So if it is in full brightness, that means the voltage is probably going to be closer to this, which could be caused by a short in either or both of these, a short in the Zener, or a short in the cap. So we're going to do a little bit of guessing here, and my guess is the Zener. Of course, when was the last time you used a 100 volt Zener? They're not exactly plentiful, but eBay is your friend, and well, let's see what happens. Let's open her up and see if we can get to that, find that diode. There's no layout information with the schematics, but we'll look for that diode. We know it comes off the brilliance pot, and maybe we can just trace it by looking at where the wires go from this pot, because that's a front panel pot, and see if we can find this diode. So the diode in question was D301, which was right here. And basically when I measured it in circuit, it showed a short. But again, it could be the cap or it could be the resistors causing that, so I had to remove it. Now that was somewhat of a chore, because if we look at the front of this, these two pots are solder mounted in this board. So I removed the buttons, and there was a nut holding it to the control panel. I removed the nuts, and there are several screws just in plain view that hold the board down to the chassis. But once I removed the nuts, the board wouldn't move. It would not come out. It was clearly still stuck in front. And finally I figured out I had to remove every single one of the front panel buttons, so I could remove the control panel, because these two pots that are soldered to the board also had a second nut holding them to the chassis behind the front panel. And why didn't I film that? Because it wasn't pleasant to watch. So anyway, I got it out. I got those out. I still could not remove this board here. There were a lot of wires that were really short, and that still prevented me from removing the board, even though now I could slightly lift it up over here and gain access to the solder junctions that the diode was in. And so finally I got the diode out, and where is she? She is here. And this is the 100 volt, 1 watt. Actually, it's not true. The manual lists it as a 3rd watt Zener diode. But I finally got it out. And of course, we don't know for sure that that's what caused the problem, but my guess was the diode. I always blame the diode. And dead short, so it basically bypassed the entire brilliance adjustment thing and just pumped the high voltage, the 1050 volts, into the brightness input on the CRT. So there's our culprit. Now, I didn't have any 100 volt Zeners in my arsenal, and I don't know when the last time was either of you used one of those. So I don't think it's very commonly used anymore, but in this case, again, eBay was my friend, and here's what arrived. Pretty cheap for eBay, right? Except I got charged another $3 for shipping, for something that you could just throw in an envelope and put a 50-cent stamp on. But okay, I won't complain. I got them after a couple of days. These are 1 watt parts. And let's put one of those in and see if we can restore the brilliance function. Now, obviously you can see that I put the board back in again. So how am I going to get the diode in there? And what I am going to do is, rather than take that board out again and try to reach in, because the CRT is right underneath this here. You can't, without removing this board or at least loosening it, you can't even get underneath. So instead of trying to solder it, I will tack solder it to these two resistors over here that are connected to the original holes of where it used to live. And then we'll see if the brightness starts to work. Okay, I tacked it into place. It is secure on both ends. And I did this with a soldering iron when I was trying to remove it. But so we got the diode in here. And I was looking at the old one again, the one I removed. I mean, this thing looks like it was made in like World War II. Made by Lucas. That's the same people who used to make those fantastic electrical systems for Jaguar motor cars. So, but she's gone. She's shorted. So let's see if we fixed anything. All right, sizzle. No magic smoke. Let's get a little straighter picture here. Okay, now we had a trace when we last ran this. So does that mean it's working now? Yes, it does. So we now have brightness control. Very nice. So we get two traces. Let's check the voltage across that zener and make sure it's doing its job. Now, we're only going to measure the voltage across the zener. Remember, if we measure it against, we're not going to measure it against the 1 kV lines over there, but just straight across the zener, and that's going to tell us if it's doing its job. So the zener's sitting at 96.2 volts. That's about what? That's about a 4%. It's about a 4% difference. But I think these zeners are rated at a 5% tolerance, so we're within tolerance. And I guess what's really happening doesn't lie. I think when we crank it up, we get plenty of brightness. So the 96 volts versus the 100 volts is not really relevant to what we're doing. So now, let's see if it can actually display anything. So let's try channel 1 first. I turn channel 2 off. We're triggering off channel 1, and this is kind of loose, but it's also hidden under the CRT, so I'm going to have to find a way to get back in there and tighten the input 1. So let's turn on the function generator, and we are at, let's see, what is that, 300. We are at 30K. We have a sine wave at 30K. So and there you go. So this, I think the doc said that this is a 10 meg scope. Let's see, can we focus this a little bit better? Yes. So let's go to the triangle. Square. Back to the triangle, and let's see if the okay, the way to test the AC input is we'll give it some offset and then switch it to AC. So the AC input works. Notice that at ground we get the squigglies in the baseline, and that has something to do with the stability going left. When you go to the right, the squigglies kind of disappear, but it no longer syncs to the waveform. And to show you that, let's go back to DC, bring it down, and if we turn up the stability a bit, it'll lose sync, and it will not sync anywhere but in this area here. But in this area, we're getting some 60 Hertz, it looks like, and to the baseline, and that is most likely a filter cap. But we're good here. Let's see if we can get this thing to sweep. I don't remember what I did last time to get it to sweep properly, but that is obviously a bit too fast. And so yes, it does show the sweep. So that part works. And now, let's go to channel 2. So we turn off channel 1. Why does it that's interesting. It still shows a trace even with both channels off. Does it disappear if we move the stability? Down at the bottom. Well, that's interesting, but anyway, let's turn on channel 2 and pump the signal into channel 2. Set the trigger to 2. Okay, let's get rid of the sweep. Hello? Let's see, is that dirt on the controls? Yes, it is. And when I had all the controls out, of course I didn't check for dirt, and I didn't clean them, and now we got to go through this whole exercise again. It's the variable pot that's doing this. Come on. But it's showing an acceptable waveform. Ooh. Yeah, the triangle is screaming for some sort of compensation. Oh, here it looks okay. There's definitely dirt in this control, which will need to be cleaned up. But back to sine, back to the square, which also needs some compensation, but let's turn down the amplitude. So it seems to be working. So as long as you display a single channel, it works pretty good. We're looking at channel 2 now, but when we go to both channels, you see it gets a bit fuzzy. I got channel 1 hooked up to the ramp output on the function generator, and you can really kind of see the chop action happening there. If we switch it to Alt, oh, that looks a lot better. So there you have the scope. Let's see, can we show the TTL waveform? Yes, we can. Let's so it is able to display two waveforms simultaneously, even though they're the exact same frequency. So maybe we can do a test where we slave one of the function generators to the other and try to display two different waveforms that are not the exact same frequency, because even though you can slave them together, you can still do fine adjustments on one of the function generators. But for its stated purpose, to make this thing work, I think we did the job. So here you have it. Now, open issues are, I checked all of the caps in circuit after discharging them, of course, and none of them showed any really ill behavior. I measured the ESR, I measured AC across them, and all of that looked good and acceptable. But this thing's ancient. Let's say late 60s. That's almost 50 years old. So it is going to need new caps. Other items on our to be done soon list. The scale illumination doesn't work. When I had this off, there's two bulbs like the power indicator in here, and the bulbs are both burned out. So I'm thinking of what to doing about that. I'm probably better off putting LEDs in there, also for the power bulb, because they're kind of strange bulbs, and they're small 14-volt bulbs with a screw base. So I'm going to look around. If I can find them, I'll try to put those in, but ultimately it's going to need LEDs. Channel 1 input is loose, and it looks like there's actually front-mounted screws, 4 front-mounted screws holding that in place, but they're behind the front panel and they screw directly into the chassis. So for that, the front panel has to come off. I have to make a pass at trying to clean all of the pots that I can gain access to. And yes, it does need needs a new power cord too, and a little bit more cleaning. You can kind of see the dust of ages here. And I'm sure I'll get to that real soon now. So this device didn't have any kind of stickers on it, inventory or calibration or whatever, so I'm guessing this came off a tech's bench, and which is kind of weird that you know, if a tech used this, how come they didn't make an attempt at fixing it? The answer is it's an older piece of shit, and they probably had better equipment. The frame around the CRT looks like somebody chewed on this in several places. But it's still a perfectly good scope, and I bet you this is an ideal candidate for an oscilloscope clock, because it does have an external X, which I guess if you turn this all the way to here, it actually goes into XY mode. So might want to have a look. I've been meaning to get a CRT clock and test a whole bunch of my CRTs with it. I mean, obviously CRT clock works best on an analog scope, but I still think it would be interesting to see how different scopes display that clock. So we got a few things remaining to do on this, but they are all issues of restoration. And as I said before, when that happens, you'll be the first to know. But it's actually got a pretty nice display, and I'm surprised that it doesn't have any burn-in, because if the the brilliance control went bad, and this was sitting on a bench, normally these things are just left turned on for 24/7, but I guess the tech had a conscience, looked at it, just turned it off, stored it, and dumped it at a thrift store for somebody else to look at, and here you go. Anyway, thanks for watching. Please support the channel with a thumbs up and a subscription if you haven't already. And until our next mystery item appears, see you then.